Okay, this is an extra exam. It's GCSE style questions, so they're GCSE level, and it's an exam we gave to Year 9 students, and it's mainly looking at forces, motion, and introduction to waves, so wave properties, and we'll go through it. So students, if I teach you, you can use this video to make improvements with your purple pens to anything that you didn't get right. Okay, so this is just the physics section. Okay, so this is the first question in the physics section, which was about waves. The diagram represents a water wave at an instant in time. Okay, so it's like a frozen motion of a wave that's just being captured by a photograph, say. Okay, a cross-sectional photograph. So the height of the wave, yeah, remember the 0 point is always the middle, yeah, because if the wave stops, or whatever's causing the wave stops disturbing the material, so in this case the water, so if the wind stops, the water will go back to the 0 level. The peaks will go down to 0, the troughs will go up to 0. Okay, so the average position will be the 0 line in the middle. This height in centimeters is also called the displacement. Remember that? The wave gets displaced from its equilibrium position. So here it's at balance. So this will be called equilibrium. Yeah? It's the center of its vibrations. So remember, waves are vibrations in a material. What is the wavelength? The symbol for wavelength is that lambda, Greek letter, of the water wave. Lambda is spelt L-A-M-D-A. Okay, so what is the wavelength? Now, the wavelength is the distance between two corresponding points of a wave, as long as the x-axis is shown in distance. Okay, so the wavelength is a length of the wave. Okay, so you can do it from peak to peak. You can also do it from the bottom of the wave to the next bottom, which is called the trough. Yeah, so the bottom of the wave is called the trough. The top of the wave is called the crest or the peak. Yeah, like a mountain peak. Okay, so the wavelength is the corresponding distance between two consecutive points, so peak to peak, trough to trough, or beginning of the wave to the beginning of the next wave. Remember, a whole wave is an up and a down, a peak and the trough. The complete wave will be from here to here. So any of those. So you can also have this as the wavelength, from there to there. Okay, so this is good revision for you. So the wavelength is 1.0 meters. So from 0, the easiest one is to do the first one because it starts on 0. So I'm drawing a dotted line up there to show you in the center of there. And when you're drawing these labels, make sure you've done it very accurately to show that you know you've gone from the center of the peak to the center of the next peak. So that gives you 1.0 meters. Then it says, what is the amplitude of the water wave? Well, the amplitude is the maximum displacement. In this case, it's the height of the wave, yeah, from the equilibrium, from the center. So it's only 4 centimeters high from the center, from here to here. So that's the amplitude. So amplitude is usually a capital A. Okay, so all of that knowledge that you had, if you watch the videos that I asked you to watch, you would know all of this information. And then this is more difficult. It says describe the differences between transverse and longitudinal waves. So the first way to show that is that draw a diagram. Now I told you draw diagrams like this, and the wavelength, for example, yeah, would be from here on this one to the center of the next compression. Yeah. Now they haven't asked you to describe the different parts of a longitudinal wave, but they want you to know that transverse goes up and down, the vibrations, yeah. So the vibrations go up and down from the center. And in longitudinal, they go left and right. So this will, when it's squashed, it'll go this way, then it'll bounce back and go that way. So the oscillations or the vibrations, yeah, either go up and down in this wave, and in these waves, they go left to right, while the waves, in both cases, may be traveling from left to right. So if the wave's going this way and this wave's going that way, yeah. So as long as the diagrams show you know the difference between longitudinal and transverse, you get 1 mark, yeah. You get 1 mark for explaining that there's oscillations up and down and sideways, so you've mentioned the oscillations bit, and then this is now putting it into words. In a transverse wave, the oscillations or vibrations are at right angles, or mathematically speaking, that's called perpendicular to the direction of wave travel or the energy transfer. So if the wave's going that way, that means the energy is being transferred that way too. Okay? So this is the language you need to be able to copy and learn and reproduce for GCSE level work. Okay? And then it says, and the difference means you've got to put transverse waves and then mention in a longitudinal. So in a transverse, the oscillations are at right angles to the direction of energy transfer, and in a longitudinal wave, the oscillations or vibrations are parallel, yes, to the direction of wave travel. Wave travels that way, and the oscillations are going backwards and forwards parallel to the direction that the waves are traveling in. Okay, so that's how they do it, parallel and perpendicular. Okay, so that's how you get the 3 marks. You need to really learn this. This is just something that you'll need from now, year 9, year 10, year 11. It will be repeated. Second question is about vectors, so which we did when we did forces. Describe what is meant by the term vector quantity. A vector quantity is a quantity which has size or magnitude and direction. So, for example, velocity is speed, which is the size of the velocity, and the direction. For example, if you're traveling north, your velocity is different to if you have the same speed but you're traveling south, your direction is opposite. So it's quantities where direction as well as the size matters. Okay, and you can represent these usually with an arrow. So vectors can be represented by arrows. So now they want to see if you know all of these terms, whether they're vectors or scalars. Okay, so you've got to tick them. Complete by ticking the correct boxes. Energy has no direction, it's just how much energy you have. There is no direction to it. Speed, if you're traveling north and south, it's just how fast you're going. It doesn't matter which direction you're going. So I'm saying, for example, if you know speed and velocity, that's worth 1 mark, because obviously these are opposites, yeah, in terms of scalars and vectors. Now, weight is always acting downwards, so it has direction. Acceleration, it will either be speeding you up or slowing you down, so it has a direction and is proportional to the force. So acceleration, for example, due to gravity will always be downwards, but acceleration, if you're braking, will be against your motion. If you're accelerating a car and you're speeding up, it'll be in the direction of your motion. So this one, it has a direction. You can represent it by the arrow. Distance is just how far you traveled. It doesn't care what direction. Whereas displacement would be the vector quantity of distance. Remember, we did all this earlier in the year. So that's 5 marks on that. If you get all of them right, you get 3 marks. If you got only 1 or 2 right, you get 1 mark. If you got only 1 or 2 wrong, you might get 2 marks. Okay. So that was question 2. The third question is called question 6 because it's been taken from a question 6 of the exam paper. The first questions in the exam paper are usually easier. The questions that come later are usually multi-parted, and they have many different parts to them that you need to be able to do. So you can see there's 2, 4, 5, and it goes over the page as well. So this one is investigating the motion of different falling masses by measuring the time taken for a toy parachute to fall from windows. Imagine you're dropping it from the lab outside and someone is timing to see from the moment you let go of it to the moment it hits the ground. Obviously, the bottom of the mass is going to hit the ground first. Okay? You're unlikely to have the parachute going below it. This is the student's method. Measure the mass of the toy parachute. So that's the independent variable. That's this thing that they're going to investigate. Drop the parachute from the window. Repeat the experiment with additional mass added to the toy parachute, and continue to add masses to a maximum of 6 different masses. So the range of data you're using is 6 different values to get a good graph, for example, if you're going to put mass against time. Describe how the student could measure the time taken for the toy parachute to fall from window. Well, obviously he's got to use a timer of some kind, like a stopwatch or a stop clock. As long as you say that, you get 1 mark. Okay. Obviously you want it to be measuring accurately, so make sure to start timing when the mass is released from the window and stop timing the moment the mass hits the floor. So if you've got the difference between those two, make sure you've mentioned when you start it and when you stop it, you get the additional mark for further detail. Okay, detail always gets you marks in exams. A lack of detail or too much of a general answer will not get you all the marks. State the independent variable in this investigation. Well, the independent variable is the thing that you choose to change. Well, that's the mass, and the time depends on the mass. So you change the mass, the time will change. Okay, so because the parachute won't be able to do so much if the mass is too high. Okay, the parachute will just resist the motion. Okay, state one factor that students should keep constant in order to make this investigation valid. We call that a fair test. So valid means scientifically fair. Yeah, that you're not changing more than one thing at a time. So the height of the window would be one way you can put it there. You're doing it from the same window each time. Let's look at the mark scheme and see what do they accept as alternatives for the controlled variable. Okay. So here's A, B, and C. Yeah. So we're looking at this section. Constant height, make sure there's no wind. That could be an alternative thing that will affect your results. Release from rest, well, obviously you're not going to push it down, and make sure you have the same parachute each time, so they have the same area to catch the air. Okay, because remember it's the surface area of the parachute which is working against the gravity which is pulling it down. Okay. And I'll just show you the rest of that. It goes on to the graph next. So they're going to give you this data from the student, and they want you to plot a graph of how the mass affects the average time for it to fall. Okay, so you can bring back to this point in the video if you want to look at how they've done it on this smaller version of the graph paper. We'll probably come back to that. So that's the first part. Here's the data. So they've done it 3 times. Why they've done it 3 times? Because they want to get a mean, or otherwise known as an average. Mean is a way where you add all the 3 results up and divide by 3, because there's 3 of them. So they've done it for all of them. They haven't done it for the third one. You'll notice they have 2 decimal places in all their data to be consistent. Yes, and normally stopwatches only measure to 2 decimal places. Okay, the mass has been shown to the nearest gram, and they're going up in 20 grams at a time, which seems reasonable. So this is the variation or the range in masses. That was the 6 data points that they got. And they want you to calculate this final point, which hasn't been averaged. What they're testing to see is that you do it again to 2 decimal places. If you do to 2 decimal places and round it up correctly, you'll get 2 marks. If you don't, you might get 1 mark. Okay? So that's all they want you to do here to show that you know how to take an average. Then you get your graph. I have plotted it. So the mass is the independent variable, yeah, and that usually goes, that's the rule to put it on the horizontal axis. So mass is the independent variable, and the dependent variable must therefore be time, and plot a graph of the average mean time taken for each mass, okay? And then you draw the curve of best fit, and you should really do all this in a pencil, yes? You need to have a sharp pencil. And the number of students who came to the exam without full equipment was surprising to me, because you need to make sure you have everything you need. Okay, so how do you get the marks for this graph? Well, suitable scales, so going up in round numbers, yeah. So I've gone up to 20 and 0.2s, yeah. It allows me to show the whole range of the data. Axes labeled, mass in grams, average time in seconds, and accurate plotting, 2 marks, okay. Now they will check to see if your plots don't look right, and then 1 mark for the curve of best fit. Okay, so there you get 4 marks for that, and 1 mark for a nice smooth curve, and the smooth curve is drawn with freehand. Okay, And then part E, so you see how long this question is? 17 marks. This is probably the longest GCSE question you can get, will be around 17 marks. The student notices that the toy parachute accelerates and then falls at constant speed. That constant speed is known as terminal velocity, and we definitely watched a video on it. We stopped the video, made sure we drew the force diagrams at different points. Now at the start, all that's happening is that the weight is pulling it down. There's no air resistance because it hasn't started to build up speed yet. Part way down, the speed builds up, yeah, and the drag force increases. And they've asked you to draw the forces on the third diagram. And this is where it's reached terminal speed. The arrows in the diagram show the size and the direction of the forces acting on the toy parachute at different points during its fall. Label the forces on the last diagram. Well, this is the last diagram. Okay, so the downward force is called the weight, and the upward resistance force is called air resistance or drag, which is kind of a type of friction. You could put gravitational force instead of weight, but you cannot use the word gravity. Gravity is a general word. It is not specifically a force. Okay, so gravity can also be referred to when we're talking about acceleration due to gravity. So be careful when you're using gravity as a force. You will lose marks. Explain why a toy parachute accelerates and then falls at constant speed. So at the start, yeah, the weight is much greater than the air resistance, or you could say that only the weight initially is acting, and therefore you have an unbalanced force situation. Remember, if you have an unbalanced force situation, that's Newton's second law, unbalanced forces. Part way down, the air resistance increases due to speed, but it's still unbalanced. Yes, still unbalanced because the weight is greater than the drag. Still unbalanced. So it will still accelerate, but it won't accelerate as fast. Okay. And then eventually the air resistance gets to a speed where the air resistance can balance the weight. Yeah, because it equals it in terms of length, and we have balanced forces. Okay. Near the bottom, since there is no resultant force because it's balanced, the parachute stops accelerating and falls at constant speed. And that's why it falls at constant speed. And that's what we call terminal velocity. So you have to be able to explain things really clearly in English. So physics is not just being able to understand forces and stuff. It is clarity and communication. And that's 17 marks for this question. Okay. Question 8 is also on forces, but this time it's on using an unbalanced force situation where the force, the unbalanced force, is equal to the mass times acceleration. So the man is pulling a child on a sledge, yeah, at an angle. The mass of the child is 45 kilograms, and the unbalanced force, which is allowing him to accelerate forwards, is 49 newtons. Okay, so he's accelerating because it's an unbalanced force. If it was a balanced force, he could be moving at constant speed, but they're telling us an unbalanced force. So this equation for Newton's second law implies that this force in this equation or this triangle is the unbalanced force. So unbalanced force is the mass times the acceleration. They want you to calculate the acceleration. Remember, if you've got the triangle, makes it easier. Acceleration is force divided by mass. Yeah, so that's the number of newtons, 49, divided by the number of kilograms, mass, 45, and it comes to 1.088. Now, you would normally round that up. If it's 4 significant figures, it would be 1.08. If it's 3 significant figures, it would be 1.09. And you can round it up to 2 significant figures, and they're giving you the units. So 2 significant figures is correct because they've only given you 2 significant figures for the force, and they've only given you 2 significant figures for the mass. So your answer should only be to 2 significant figures. They will not, like in maths, tell you how many significant figures you should put. They want you to think about it, and you decide how many significant figures you put. Okay? Suggest a reason why the man must pull the sledge with a force that's greater than 49 newtons. Okay? Well, I've put because he must overcome friction between the sledge and the ground. There will be some resistive forces that he needs to make sure that is not slowing him down. So this is part A, and here's a mark scheme. So any suitable suggestion, example, friction, yeah, which is what I put. Ground might not be level, that's true. So if someone put that, it means they're thinking. Towing rope direction is at an angle to the ground. You know, in the diagram, he was pulling at an angle to the ground. Yeah, and by the fact that he's pulling at an angle to the ground, not all of his pulling force is pulling in the direction of the acceleration. Yes, so the angle means that he's got to put extra force in than 49. And I think this is probably the best answer, but that's probably the most complicated. So it's because he's not pulling in the same direction that the sledge is moving, and he's pulling at an angle. So he's kind of also lifting the boy up. Okay? So that's part C. Part 3 of A. Part B is a velocity time graph. Now we did these in class, and so velocity is in meters per second. They haven't put the unit there, which is wrong, and they haven't put the time there, which is normally in seconds. Okay, so it's just a general shape of the graph, and what they want you to explain which feature of any velocity time graph shows the distance traveled. Well, that's the area under the line. Remember, we said area of the triangle, area of the rectangle, and area of the triangle. So here it's accelerating. The area would be half base times height. Then it's moving at constant speed. Yeah, that will be an area of rectangle. And while it's decelerating, it will be another triangle that you could work out the area underneath. But the concept that the distance traveled is the area under velocity time graph is what they're seeing that you have learnt from the first term. Okay. Then from O to A, it's accelerating. They want you to describe the motion of the sledge during the journey shown by the velocity diagram. They want you to be clear. From O to A, it's accelerating at a constant rate. Yes? So it's a constant acceleration because the steepness doesn't change. It's a constant acceleration. So always try to add some more. From A to B, it's moving at constant velocity. So they gave us numbers here. We could read what the speed was. Yes? So if this was 10, 20, 30, 40, 50, 60, it would be 65 on that scale if it was going up in tens here. Okay? Again, you're saying it's at constant velocity. So you're not just putting one word. Then deceleration for part C, B to C, is here. But you can see this slope is not as steep as this slope. So you should put something extra. For the third mark, we're not going to give you the third mark unless you add some detail. So the deceleration, the rate of deceleration, for example, you could say, is less than the rate of acceleration in O to A. Yes? So because it's less steep. So try to always add a little bit of detail if you want to get the full marks. And that ends this section of the video. And that's the physics section. Chemistry and biology, they have done the mark scheme for you. I don't know if they're going to give you a model answer like this. But I thought since I have the YouTube channel, I'll put it up there. Most of you have already watched it for previous videos. And of course, this will also be there for next year when you're in GCSE, because this is the first topic in GCSE. Hope you found it useful. Make sure you like, share, and subscribe. If you found the video useful, show your appreciation by giving me a thumbs up and share it with anyone who hasn't got my video channel yet. Okay? And I'll see you at work, and this will be what you're doing once we get your papers back from whoever's marking it. Okay? Bye for now.